All right, welcome. In this video, we are going to go over some hints for this lab. So it's the lab on page 9. Make sure in order to do this lab, you need to watch these videos. So what we've done is we've taken a 90-minute lab and boiled it down into two videos that are less than 10 minutes each. So watch the video, answer these questions up here. And so there's a part 1 video over here, and we show you some lab equipment, and we take a look and make a graph of concentration versus absorbance. And then in part 2, we collect some more data, and then we're going to do some calculations with it. So in this video, I'm going to give you some hints on how to do these calculations in case you are feeling stuck here. So what we do initially is we are in part 2, we are making a equilibrium mixture. Whoa. In a test tube, and let me kind of sketch this out for you. And what we did is we want to mix together our two reactants, right? And so like in mixture A, we mix together 4 milliliters of the iron solution, and we mix together 6 milliliters of the thiocyanate solution. There should actually be an extra 0 here. I'll go through and fix that later. So this is 4.00. And we mix those two together. And then these are our reactants. But notice that when we mix them together, they get diluted in the process of mixing. And so in order to figure out what the initial concentration of our reactants are, we actually have to do a little dilution calculation to figure that out. Because when you combine them together, now the new volume is 10 milliliters, right? 4 plus 6 is 10. And so we need to figure out what the concentration of iron is in the actual reaction mixture, because it's not actually going to be 0.0028. It's going to be something smaller than that because we've diluted it in the process of mixing. And if you run low on space here, you could use the area off to the side. But basically, this is an M1 V1 equals M2 V2 calculation. And like for the iron right here, the initial molarity is 0.00280 molar. The initial volume is 4 milliliters. The final molarity is the thing that we don't know. That's what you want to solve for. And the final volume is 10 milliliters. So when we solve for this, it will give you what the real initial concentration of iron is in the actual test tube. And then you're gonna do the same thing down here for the thiocyanate. Similar calculation, right? You just have different numbers. So with the thiocyanate, it was 2,1 molar, and we use 6 milliliters. And then we're trying to find what the final molarity is, but we're diluting it to 10 milliliters. So you can, plug these in your calculator, solve for the final molarity. And that's the same kind of calculation you're going to do here for equilibrium mixture B. So we had 2 test tubes that we made. This test tube we made by mixing 5 milliliters of each of the reactants. So they're going to have, since we use different volumes, they're going to have different initial concentration of reactants in mixture B versus mixture A. So that's step 1, is to do those calculations. Okay, so continuing on, you are going to, next what we're going to do, so what we did here in part 7 is we just found the initial concentrations of your iron and your thiocyanate. So reminder, what we're trying to do here is we are trying to find the K value for this reaction right here. And we're going to use an ice chart to set it up. There we go. There's a nice little ice chart. So what we have just done in problem 7 is if we take our answer from here, that tells us the initial concentration of iron. And this right here tells us the initial concentration of thiocyanate. So it's what their initial concentrations are in the test tube before any reaction occurs. And then our initial concentration of the iron thiocyanate is 0 because we did not add any iron thiocyanate. We only added these 2 things. So these 2 have initial concentrations. This one's initial concentration is 0. So the next thing we want to do is we are going to use our graph from part 1. So if you look at question 5 in part 1, we made a graph that showed the relationship between absorbance and the concentration of iron thiocyanate, because iron thiocyanate is the red stuff. Okay, so the absorbance that we're going to measure here can be used to tell us the equilibrium concentration of the iron thiocyanate. Okay, but we need to know the relationship between absorbance and concentration. That's what we did in part 1. So look back at the video from part 1, question 5. It shows you what this graph looks like, and we calculated the slope of this line. And the slope of this line, I believe, was 2,410. So that is the slope of this line. So what that means is the absorbance is 2,410 times the concentration. Let's see, I'll just put in M for molarity. Okay, so over here, what we want to do is we're going to record the absorbance from the video. So we're going to watch the video, we're going to record the absorbance, and then for 2 solutions, we got 2 different mixtures, and then we are going to solve for molarity. And the way that we solve for molarity is we're going to take this equation and we're going to rearrange it to solve for molarity. So the concentration is going to be, if we rearrange this, the absorbance divided by 2,410. That's going to give us the molarity. So you're going to take your absorbance, you're going to divide it by the slope of this line, which is 2,410, and that's going to tell you what the molarity is. So notice how it's just like a linear graph here. If you know y, you could solve for x, or vice versa. So what we're doing is we're measuring the value of y, and we're using that to solve for x. So once we find the molarity of your iron thiocyanate, this is going to give you that value right here. So now we're going to know the initial amounts of iron in thiocyanate, and then we're going to be able to calculate what the equilibrium amount is for iron thiocyanate. And at that point, we're going to have our ice charts set up enough where we can just fill in the blanks here. So if this is 0 and we know what this number is here, we can figure out what the change is. And then when we're filling in the change, we know that the sign on the right is going to be opposite sign on the left. So in this case, we're making products. So the change over here is going to be positive, and we're going to be using up these reactants. And then we're going to be able to add up your initial and your change to get your value at equilibrium, and then plug those into your K expression, and we are good. Okay, so we are going to then, and you're going to have 2 of these, right? So you're going to have 2 ice chart setups because you ran 2 experiments. So there is test tube A and test tube B. So we calculated, initial concentrations for test tube A, and you're also going to calculate them over here for test tube B. And then you're going to calculate the molarity for test tube A and for test tube B. So you're going to have 2 ice charts, and we should see that they will both give you pretty similar K values, because the value of K, it's a constant, so it will be constant no matter what our initial conditions are. So we should get similar K values for both of these calculations. And then what we want to do next then is, once we calculate K, a related thing we could do is we could actually calculate the value of delta G. So down here, based on our K value and whether our K value is greater than or less than 1, we could figure out if it's reactant or product favored, and whether we predict the delta G to be positive or negative. And then we can actually calculate delta G using this equation right here. So delta G equals negative RT ln K. And if we look over at our equation sheet, remember R is this right here, 8.314 joules per mole Kelvin. T is our temperature, which we want to be in Kelvin. So, and the way that we find the Kelvin temperature is we take the Celsius temperature and we add 273. So our Kelvin temperature is 293. And then we take the natural log of our K value, which we calculated up here, excuse me, in question 9. And again, if I didn't give you enough space in question 9, feel free to use the space off the side like I'm doing here in this video, or create some more space for yourself there. whatever you'd like to do. Um, and yeah, so then you're just going to plug these in and solve for delta G. Okay, so hopefully this kind of helps you think about what these calculations should look like. You can send us follow-up questions, send us a chat message, stop by Afternoon Tutorial if you have further questions on this.